This is Space Minds by Space News. In this episode, co-host David Ariosto talks with Lee Rosen, who reflects on his SpaceX tenure, co-founding ThinkOrbital, and where industry is headed. We then discuss the latest news, including the increasing number of layoffs, and wrap up with trivia.
Lee, thanks for making the time. I want to go back to around 2010 when you were with the Air Force. And I want to maybe set the scene a little bit here. You were in Cape Canaveral. You're waiting for then President Barack Obama, who would later give a speech about this increased reliance on private space companies. But at the moment, you're standing there in this early SpaceX hangar, hanging around with young Elon Musk with a lot of time to kill. And that moment became sort of a turning point in your career. And you just started chatting about crazy things like landing rockets upright and going to Mars. And so I wanted to start there. Like, what did you talk about, and why was that such a turning point?
Yeah, it was definitely a seminal day in my life and my career for sure. And the first thing I really remember about that day was we get to this hangar. You had to be there early because it's the president, right? No one can come in and no one can go out. There was pretty much just me and Elon hanging out in this hangar. And the first question I think he had for me was, "Who the hell are you and why are you here?" Which was an interesting question as kind of the launch group commander on the base. And, well, I own, this launch pad. And he's like, well, no, this is the SpaceX launch pad, which is a very different kind of concept for how things may have been in the past. So it was right then and there, I knew that things were going to be different. And I had the opportunity to interact with Elon quite a bit as SpaceX was getting the launch site and starting to build up capability on that launch pad. Just the opportunity to sit and chat about all those things that you mentioned, David, was an amazing opportunity. And we talked about well, if you're going to land a rocket, how would you do it, right? And we talked about well, I said, how about some aerostructures on it? Well, too heavy. Well, how about a parachute? Well, that won't work on Mars. And then you start really scratching your head going, this guy is either a little bit nuts or is onto something here. And then we started talking about propulsive landing and those kind of things. And, it seems so elemental to where we are today. But man, that vision and that foresight was very clear to me right from the get-go.
One of the funny things is I think about this in terms of your trajectory and how it runs in tandem with SpaceX in many ways, because you were there for a better part of a decade, but you later became director at Vandenberg for SpaceX, and at the time you had to effectively convince military officials that it was okay to send what was tantamount to a missile to come back at them. I'm talking about this relatively new world of reusable rocketry. I'm kind of curious, like what those conversations were like and how much like the eyes bugged out of the head when you talked about this.
Yeah, the whole landing thing was so different than anybody had ever thought about. And we had first contemplated doing water landings to make sure that we understood the technology and that our ability to hit a point on the Earth with the rocket was good. And even our first launch at Vandenberg, we did a water landing successfully and came down in the area where we wanted it to come down. And talking to the official at Vandenberg, everyone knew that this was an inflection point, right? That things were going to be changing, and everyone, there was very little pushback. Of course, the safety community was going to be concerned about it and things like that. And I think there were people in the community that knew that this was truly game changing, right? And and some of those, and I'll give credit to folks like Brigadier General retired Wayne Monteith, who was the commander at the 45th Space Wing when we did the first landing. And the infrastructure there at the Cape, the proximity of Port Canaveral, all of those kind of things were things that had to be taken into account from a safety perspective. But General Monteith at that time knew that man, this capability was really going to change the game and really put his stars on the line, saying that we have done the analysis, we understand what's going on here, and we believe that SpaceX has the capability to make this happen. And the first successful landing for SpaceX was the land landing on the 21st of December of 2015. I remember this like the birth of my children, right? And I think from there on out, it became clear that we clearly knew what the heck we were doing, and the rest literally is now history.
I mean, but
Or
there was
yeah, sorry.
Yeah, but just like also this idea that you're coming from the military, you're coming from a federal agency, and you're coming from a place where budgets mean just different things, I would think, in that context. So everything from just building roads on the cheap to what it take to maybe go like www.rocketspareparts.com. I mean, I'm being facetious a little bit here, but I mean that was kind of tantamount a little bit to those early space days and excuse me, SpaceX days. And I'm wondering like how that translated. And I kind of want to get into this, how this translated into where you took this. But before we do that, you know, you were instrumental with Falcon 9. You and Frank Tibor, who also works at ThinkOrbital, where you're at, were instrumental in terms of Starship. These are pivotal technologies that we're looking at are only starting to come to bear now. So, like, how did that company ethos drive that? I'm wondering.
Which, which company ethos are you talking about? The ethos for SpaceX, the
For
ethos for
SpaceX,
ThinkOrbital? Yeah.
yeah, SpaceX starting,
Yeah.
and then we'll get to ThinkOrbital.
Yeah, for sure. So, it's kind of funny, Dave. I think the fundamental thing that I took away from Elon was the only constraint that you really have to deal with is physics, right?
Mhm.
And all the other stuff was kind of made up. And there are good reasons for some of those rules, and there are no reasons for other of those rules, right? And if we over constrain problems and don't understand the fundamental physics of those problems, then you're never going to be able to solve those problems. So if the physics closes and you can make that work, do that first, and then we'll worry about all the other stuff, all the rules, all the regulations, and things like that. And I think that was ingrained into us at SpaceX. That if you really want to solve a problem, if the physics doesn't close, don't go there. But if it does, then we'll fix the other stuff later.
The,
And I think you talked about kind of this other part of the scrappiness ethos of SpaceX, right? And what the government thought about it. And it just reminds me of the first time at Vandenberg we had to go buy tanks for RP-1, the rocket propellant one, the kerosene that feeds the Falcon 9, right? And we found these tanks that were at a chemical company lying in a field in Houston, rotting on eBay, literally. And
right.
and normal tankage costs on the order of $10 a gallon for a new tank, and then a used tank was like 50 cents a gallon or something like that. So it was an order of magnitude savings, right? And
Yeah.
we sent somebody down there, and they're like, well, they're kind of crappy. They're a little bit rusty, but they might work. And we got one of the tanks back up to Vandenberg. And I remember getting into the tank and poking at some rust with my pen, and a hole went straight through the tank. And I went, wow, this could be interesting. But we got them cheap, which was fantastic. And we did the repairs on the tank, and we brought them up to the American Society for Mechanical Engineering Standards and all of those kind of things. And we showed this to the government, and they went, you bought these tanks on eBay? We're like, yeah, we bought them on eBay, but here's all the documentation, here's all the testing, all those kind of things. And again, if you bring the data, if you show that these things are possible, then it really changes a bunch of minds, right? And that's kind of we did that on several different systems to show the government that the data speaks, and that was the approach that we took.
I remember hearing from another former SpaceX employee that there's a single S in between the line or the word scrappy and crappy in that sense, and the SpaceX sort of
There's one
prides itself being on the latter form, that
small
line.
S. Yeah.
Right, Right. Oh yeah, small s, exactly. This pace though, the pace of all this and the speed of the iterative approach and the sort of design structure in terms of vertical integration. Um, I wonder like how that sort of plays into like just the exhaustiveness of the effort and maybe even sort of the burnout that the team can experience and how that sort of plays into sort of long-term structure.
Yeah, it's funny because we used to say it's if you remember the old Navy saying it's not just a job, it's an adventure, right? So SpaceX was not just a job; it was more of a lifestyle, right?
Yeah.
And you have to be ready to give it all. Another great thing about Elon was that he would never expect you to do anything that he wouldn't do himself, which is a hallmark of most leaders, right? Is that he would put it on the line, he would work the hours, he would make the decisions, all of those kind of things. And that was a very powerful incentive for people to want to work hard. Not to mention, you're working on like the coolest technology on the planet, doing amazing things and really changing the game. And, when I first got into this, I had no intention of retiring from the military. But after talking to him and knowing what the situation of the supply base for rocket launches in the United States was and had become, where an entire industry from a commercial perspective had been offshore to our great friends, the Russians, and to the French, right? And that there was monopoly kind of being established in government space launch and the prices were going up, that we had to have competition. We had to get more capability on orbit for warfighter, and we were going in the reverse direction. And Elon really presented the only opportunity to reverse that very dangerous trend.
What's interesting though about this is I think in a lot of the pushback that you had at sort of the early onset, and I'm talking even sort of like old Apollo luminaries that were very, very vocal against this private sector approach that was being adopted. I mean, I don't want to suggest that SpaceX and Blue Origin and other companies at that point was just sort of the genesis of commercial space, but at least in terms of this modern era, that those were sort of the embryonic stages. But questions about human space flight are wildly different than having this iterative approach of Falcon 9s and starships and it blows up on the pad or it heads out to sea and like it's no big deal, get it back and then do it again. That had to be as sort of your purview kind of in the back of your mind a little bit as you started to push forward, like how applicable this was when human lives were really on the line.
Yeah, I couldn't agree with you more. It's very different when you're strapping your friend on top of a rocket, or you got to tell little Johnny or little Jill that mom or dad is going to come back safely, right? I mean, that's a lot of pressure. It's a very different ball game. So we built the whole system from the get go with humans in mind. Even the first cargo version of Dragon had a window on it, right? The cargo didn't want to look outside, or the mice that were being launched didn't care, but it had a window on it. And I think it was that foresight that we knew that human space travel was essential and part of the vision of SpaceX, right? To make life multiplanetary, to get large numbers of humans to Mars. That was always in every part of the calculus a big piece of what we did every day. Is this antithetical to getting us to Mars or not? And should we continue down that path, right? And I think that you talk about kind of the things that drove the company. That whole imperative for making life multiplanetary was kind of in the room every time you made a major decision. So
Yeah.
that piece was important. Yeah.
The window question is even actually kind of almost emblematic of kind of a broader shift within the industry itself in terms of like the push towards more autonomous systems as opposed to, I mean, granted, when you're launching on Falcon 9, there's not a hell of a lot of steering going on, but there's this great, at least from inside the vehicle itself, but there's this sort of this pivot a little bit more in terms of relying on automated systems and what that looks like when you talk about things deeper in space or interplanetary space or the nature of landings. I want to talk about that now because I think now that we're in space, so to speak, that seems to be where ThinkOrbital is focused. This is a space infrastructure company. you're talking about building things at scale, developing the tools that you need to build in scale. I mean, how else would you go on to build a Death Star in space if you don't have the tools to essentially do that? Because there are size constraints, right? So, I think when you don't have those, you start to develop the techniques. I mean, I guess it's wrong to say the sky's the limit. Space is now the limit in this sense. But explain a little bit more to me about what those tools are, specifically with regard to these welding guns that you have, because you can't do this in the same way. You can't do welding in the same way in microgravity in the vacuum of space. Just the simple fundamentals of physics, where conduction and convection just don't work the same way. So I was wondering if you can maybe just give us a primer there first, and then we'll kind of get into more what you're doing.
Yeah, for sure. And I think, again, this was, at SpaceX, we were always looking for ways to overcome constraints. And we had the opportunity while we were there to overcome the fundamental constraint of space, which was getting there, right? And now launch is everything we had hoped it would be, right? It's reliable, it's affordable, it's super high cadence, all of those kind of things. For $100 a month, you can have Starlink and 250 megabits per second at super low latency anywhere on the planet, right?
So you're still not
Another
working for SpaceX? It sounds like you're still working for SpaceX here, Lee.
I'm always working for SpaceX, believe me. I still have a vested interest, shall we say.
Oh, okay.
But I do believe, I wouldn't say it if I didn't believe it. So, those constraints were huge. In my estimation, another huge constraint that we have to overcome in outer space, and there are tons of them, is the size of things in outer space, right? Because today, everything in space, even the venerable International Space Station, is tiny compared to any terrestrial application, right? And the reason why that is because we're fundamentally constrained by that rocket, right? We call it the tyranny of the payload fairing, right? And the way we do things in space is the way we've been doing it since the beginning, right? You build it on the ground, you cram it inside a rocket, you launch it into outer space. Now, if you're super creative, you can do some origami to increase your outer mold line, but your inner mold line is kind of
Games,
fixed,
web
right?
varieties, of course. Yeah, yeah.
Right. So the volume of whatever you're trying to do, and for human habitation or for research and things like that, that inner volume matters quite a bit. Is fixed by the size of the rocket, and even a huge rocket like Starship with a 9-meter diameter, it's still not a place I want to live for a long trip to Mars or for an extended period of time in outer space, right?
So then
So
how
you
how
have
do you
to,
do the welding then? How do you do the welding in
yeah.
space? Yeah.
Well, the welding in space is interesting, right? Because Earth, you need carrier gases to do on terrestrial type of welding. So that kind of welding doesn't work in the vacuum of outer space. But there's a type of welding called electron beam welding that has been around since the 1960s. It was developed for applications where you needed super deep penetration
By the
and
Soviets, in a way, right? These are Soviet initiatives. I mean,
yeah,
clearly.
some of it was done. The Patent Institute in the Ukraine is, one of the original folks that pioneered this technology, as well as the Welding Institute in the UK. But they developed this technology called electron beam welding, and basically you take a stream of high-speed electrons and get two negatives next to each other. Those electrons repel each other, and they travel down the distance of a gun. And we use this at SpaceX actually to do some of the welding on the thrust chambers, but they're huge guns, right? They're super high power guns that really weren't suitable for outer space. So we developed a gun that you can hold in your hand here. Basically, we get the top of the gun to minus 20,000 volts. We get a little filament to 20,000 volts. They repel each other. They travel down the length of the gun, and about 4 centimeters from the bottom of the gun, you've got the perfect focal length for doing welding and melting things inside of a vacuum, right? And in fact, it only works inside of a vacuum. If you have a bad vacuum, or if you're trying to do this in air, it will short out. Those electrons want to go anywhere other than to that grounded piece of metal that you're trying to melt. And it makes actually pretty beautiful welds. I'll just do a little show and tell and show you kind of some of the nice welds that this thing can do. Yeah, super deep penetrating, nice welds.
So the
And
old Air Force guy is building guns in space. This is what you're telling me here.
Well, that's kind of the interesting thing
I'm
about this technology is it's kind of like a Swiss Army knife, David. You can use it to weld. You can use it by electronically steering the beam to do cutting. And let me show you an example of that, where basically you're sculpting metal away from the center line, which is cool because you don't generate debris, nor do you generate thrust when you
Yeah.
do that, which, if you piss me off, I'm going to sneak up to you and cut your solar panels off, and you won't know until the lights go up, essentially.
All right.
So,
So the last thing I want to talk to you about a bit
yeah,
is technology that you're developing with regard to X-ray capacities and the
right.
capacity to look inside satellites, potentially from several kilometers away. And so this is useful not only in terms of repair and maintenance of existing satellites, but also in the geopolitical context, what actually is inside that Russian satellite, a little bit of a peer inside from a few kilometers away. I think you likened it to sort of the U-2 space plane era in space, and in terms of that sort of high altitude reconnaissance that you saw back when. Um, like explain this a little bit more to me, both in terms of the technology, but like what does this mean in terms of the next era, in terms of transparency, and in terms of just the broader dynamic between nations?
Yeah, that's a great question. So we talked about kind of the Swiss Army knife capability of effects of this electron beam gun that we have, right? And one of the other effects is that if you take that stream of electrons, that it's traveling very, very quickly, and hit a dense piece of metal, and slow it down, you generate a lot of heat, but you also generate X-rays, which at first we're like, great, we've got our own X-ray source. We can inspect the welds that we just did. And then kind of from my Air Force past, working in the space superiority world, I'm like, wow, if we can generate X-rays, I had just had a hip replacement, right? And I got a lot of X-rays done. I'm like, imagine if I could use those X-rays to look inside, like the doc looks inside to do my hip replacement. Why wouldn't we do that in outer space? So we started doing some experimentation with the low power X-rays that we were getting off of the gun. And then I was up at the National Space Council briefing, and they said, well, we have this problem. We believe that the Russians are hiding capability inside of satellites. How far away could you be so it's not a provocative event to do inspection and characterization of satellites? So we went back to the drawing board, and now we can use different types of X-ray sources and focusing of those X-ray sources. I'm not going to tell you the how, but because that's pretty company proprietary. But the
Tell me off the record.
itinerant effect is we can focus those X-rays down to get it onto a target and basically look inside a satellite, penetrating up to several centimeters of the skin of a satellite, looking actually through the satellite at about 10 kilometers to tell if there's something in that satellite that shouldn't be there. And the other cool thing about X-rays, like when you take your luggage through the TSA checkpoint, right? Not only does it look inside and get an image of the inside of your luggage, it also kind of can screen the materials that are inside. There's some interesting X-ray effects that you can use based on the detector and the software to pull out different materials. So that will also be helpful in trying to characterize and determine the intent of enemy satellites or adversary satellites. And I think that's kind of the key here from a geopolitical perspective, the ability to attribute capability to others, much like during the Cuban Missile Crisis, as you mentioned, the U-2 was able to show the world that the Russians were doing nefarious things on the island of Cuba, right? So why not have that capability to do it in outer space? And oh, by the way, if I want to do it for anomaly resolution or things like that, you can also get great imagery up close of the internals of your satellite too.
Cuba being my old stomping ground, believe it or not. But all right, Lee, founder of ThinkOrbital, a space infrastructure company based up there in Colorado. I can't thank you enough for taking the time to spend here with us on Space Minds.
Thanks so much, David. Really enjoyed it and really appreciate your chance to do this.
Now for Space Takes, where our hosts tackle the buzziest industry topics.
So, Mike, what do we have going on this week?
I wanted to talk this week about this real kind of juxtaposition I think that we're seeing in the space economy right now. The last week or so, we've heard a lot about layoffs, and I think maybe it started with Boeing. They've said they're probably going to reduce the number of folks working on space launch systems, SLS, by about 400 people by April 2025. Um, Jared Isaacman, who's President Trump's nominee to be the NASA administrator, has said, he finds it to be a very expensive program. Blue Origin laid off about 10% of its workforce. They've said they need to restructure and focus on operations and manufacturing. That was about 1,100 people. And there's this reduction in force that's happening across the federal government. And for NASA, the expectation is that's going to be between 750 and 1,000 people. So it's this, that's a lot of folks collectively and a lot of folks in the space workforce. At the same time, we're hearing, hey, this is maybe one of the best times to be in space. This is an incredible booming market. This is, there's more and more money here, particularly because of government contracts. And so I think what's hard is trying to make sense of this, and part of it might have to do with so many companies pivoting to defense. So, it feels like every day I open my inbox and there's another company saying, "Hey, we are also a defense company." But it's a very strange time because there's this incredible level of optimism, but then what's happening with employment numbers sometimes doesn't seem to match it.
I think what's also interesting is that you look at the context of 18,000 civilian employees within NASA, half of 1% of GDP. I mean, those numbers are pretty small when you compare them to the Apollo numbers when we're looking at 4% of GDP. And
Yeah.
I think it's just interesting in this broader context. Like you said, like you hear all this excitement about space and growth and the investment potentials, and you have the World Economic Forum that's projecting like $1.8 trillion economy by 2035, up from 630 billion and from 2023. And but I actually did a little bit of parsing the data, and it was interesting to me in the sense that, like, if you look at the numbers between like 2012 and 2021, there was actually like a little bit of slight contraction in the space economy. And this is like if you go by the numbers in the Bureau of Labor and Statistics. Where you do see growth are some of the big players, right? You mentioned defense, but also what plays into that is SpaceX, Blue Origin, despite that 10% cut. And it's just interesting to me in the context that you literally have one of the major contractors, the heads of which is literally in the White House, making decisions about what should be cut and what should be not. It puts SpaceX in a very enviable position in this. And in the context of the broader industry, it's just fascinating to watch sort of this ebb and flow and sort of almost like accordion-like structure of how the space economy is progressing and is expected to grow, but maybe grow unevenly.
Yeah, and I think that's right. Like growth never comes, straight up a hill. It's always there's surges and retractions, and um, I think this could be viewed by some as maybe a maturing of the market, that there is this growth and then contraction, but um,
Consolidation, yeah.
yeah, and I think what kind of the question it raises for me is, you know, is it going to be more of a focus on operations and manufacturing, like Blue Origin said? Is it what will be a priority? What won't be a priority? What won't get done? And not to cop out, but I think those are kind of wait and see questions. But I think that's what we're really going to be watching, and where which programs won't have the jobs they once did.
And I think the jobs question is a really interesting one because I mean, you think about this in terms of jobs. I mean, these are tens of thousands of jobs, both public and private sector jobs. But you think about this in terms of efficacy. I mean, you look at this objectively, and there's got to be questions here. I mean, you look at SLS. I mean, this is a $3 billion a year program, which sort of timetable unknown. It's oh, by the way, using refurbished space shuttle parts. when you look at Orion spacecraft, I mean, this is a billion-dollar program that's been running for 2 decades, and that still hasn't flown anyone in space. You look at things like Lunar Gateway have been plagued by overruns and delays, and there is this sort of broader question of sort of like what are we doing here? But
Yeah.
on the other side of it is just, do you want the guy whose company that has tallied $15 billion in NASA contracts deciding where to make those cuts, especially when Starship is a direct competitor to SLS? So, the old conflict of interest questions in Washington don't seem to be applying as much here.
Yeah, the other thing that I've been thinking about is there was this moment 7, 10 years ago where we started to see fewer and fewer traditional engineers work their way up into the C-suite at space companies and more traditionally trained business folks. And I wonder if this is another step like that. It's a further maturation of the space market a little bit.
Yeah.
I wanted to talk about another story this week as well. One about a geomagnetic disturbance that took place May 10th and 11th of 2024, which, I know it's hard to think back. Hey, what was I doing in May 2024? But it was this interesting event. It's come to be known as the Gannon event, and it was when dozens of solar flares sent at least 5 coronal mass ejections toward the Earth, and it led to led to all of this kind of really disastrous events, both in space but also on Earth, which is not something you normally hear. And where I thought it was particularly interesting was it caused some interference with GPS satellites. GPS satellites are used very, very extensively by farmers. And one of the great details that we had in a story recently was that there was an analysis that said, geez, roughly $500 million, $500 million in corn and lower yield and revenue was due to this storm. And I thought, man, that's just a fascinating story about, we think of space as, kind of this pristine environment where everything can work according to science, but there really still is this degree of unpredictability about what's happening in space and what it means for all of our satellites.
I don't know that you could have found a more close to home sort of anecdote in that sense about how space sort of affects local economies than farming, essentially, right? I mean, the notion that so much of our economy, when it comes down to just tilling the Earth, is reliant upon machines that are based on these orbiting satellites in such a profound way, and it's only growing. I mean, we're looking at, I think I saw a statistic that there's something like 191,000 satellites potentially put on order for orbit in the next 10 years. Now, accounting for only like 10% of those actually come through, because obviously, 191,000 total won't go into play. Oh, by the way, about half of them are China. But I mean, even 10% of that, we're still looking at a threefold increase in terms of satellite presence on orbit. And the nature of how our economies are sort of reliant upon this, I still don't think is like really fully understood. And so what outages represents are potential real disruptions to people's lives on orbit. It's remarkable, really.
Yeah, and I think there's also it can make landing a plane harder. It can make using GPS hard. But there's just all sorts of second and third order effects, I think, that we probably take for granted.
And so, like, how do you combat against this? And I think this sort of like leads into our next story.
Right.
Noah is we're looking into essentially possibility of putting new satellite systems in space at these sort of observation points between the Earth and Sun to sort of help space weather forecasters kind of get a jump on solar flares that might like lead to these geomagnetic storms. And I thought it was interesting in terms of this story, not only in terms of the preparedness aspect of that, but the propulsion mechanisms by which they were doing it, which were solar sails. I mean, it just
this is such a crazy term. Like, this is a crazy term, but
Right.
once you describe it, it starts to make sense. So go ahead.
No, I mean it just it's almost like harkens back to those early days of these Polynesian wayfinders that are just jumping between islands and using the sails. But I mean, essentially, like it's this idea. It's this idea that actually dates back, and I love digging into these things, like as you know. But I mean, it dates
Yeah.
back to the 1600s when Kepler actually wrote to Galileo after having watched a comet streak overhead, and he noticed that the comet's tail appeared to be pointing away from the sun, which sort of made him wonder whether the sunlight was exerting a force like the wind against the sail. And so, like at the time, it like conjured these ideas, like could sunlight be then employed like wind to traverse the cosmos, like in the same way that sailors navigated the open seas? And in that letter, this is what I love. It's dug into the letter. I found it, and it said, Kepler wrote, provide ships or sails adapted to the heavenly breezes, and there will be some who will brave even that void. So it seems like we're in a time of braving these voids that Johannes Kepler back in the 1600s in his letter to Galileo had mentioned.
Yeah. And so the idea is to get as close to the sun as possible to be able to predict some of these solar events, solar storms, and hopefully be better prepared for it and understand that, hey, when something like this happens, it's gonna cause massive changes, not just in the space economy, but also potentially here on Earth as well.
Yeah. And it's also interesting, not only in terms of the position, but just how effective these things can work. I mean, it takes a long time to build up speed, but once you do, by virtue of sort of that lack of friction in space and sort of that microgravity environment, that vacuumous environment, you can potentially get these light sail craft up to fractions of light speed. I mean, it sort of harkens back to what Yuri Milner and Pete Worden, former director of Ames, Navi Loeb at Harvard, has been working on at Breakthrough. This idea of like these laser-propelled light sails that can
Yeah.
send these tiny spacecraft, like the size of a postage stamp, careening out at like literally fractions of light speed to even our nearest neighbor, Proxima Centauri, in literally just a few decades. I mean, this theoretically, actually. So, this is a
Yeah.
star system that would, by conventional means, take thousands upon thousands of years, and now you're reaching these things in the course of a human lifespan. So what that means in terms of the nature of how we think about propulsion systems and how we orient our crafts in space, and the early detection systems are just sort of a first step. It's fascinating stuff.
Yeah. It's as we've talked about, it's science fiction come to life.
Space Loop. Let's close the loop with trivia and audience perspective on this week's space news.
Okay, on to trivia. From last week, we asked what recent discovery did the Euclid mission make in the constellation Draco? Well, the answer to that question is an Einstein ring, named after Einstein because it was he who had predicted the bending of light through his theory of relativity. Essentially, as light from a galaxy bends as it's moving past a massive object like another galaxy or a cluster of galaxies, and thus creates these visible rings, and effectively that's what Euclid discovered. Okay, so today's trivia centers on the moon, and our moon will start to pass into Earth's shadow essentially on March 13th, and it's going to create a lunar eclipse, and that happens when the sun, Earth, and moon align so that the moon passes into Earth's shadow. Here's the question. Lunar eclipses are sometimes called A, a blood moon, B, a supermoon, or C, a harvest moon. Pay attention, and we'll give the answer on our channels and in next week's podcast. Mike,
That sounds
what's
great.
left?
I'm trying to think of, I think all of those maybe already be rock songs, right? We want to hear from you. We want to hear what you're thinking about where the space economy is headed, and also how should we think about some of these major space weather events, and what kind of preparations should take place. Feel free to email us. We're at spaceminds@spacenews.com. Thanks so much for joining us this week. I'm Mike Bruce.
And I'm David Ariosto. Thanks so much for listening, and we'll see you next time here on Space Minds.